Hello. Yeah. See the question number 13. Which of the following is not correct for alloys? German silver, copper, zinc and nickel. That is correct combination. Brass, copper and zinc only. Brass has copper and zinc. This is nearly 20 to 40% of zinc, and copper is 60 to 80% of copper. Next, bronze and bell metal. Bell metal and bronze both have the same composition, means same elements. Only difference here is 20% of tin and 80% of copper is there. Bronze has relatively less percentage of tin, slightly. That is combination. So among these, you can identify the incorrect is brass. Brass is only copper and zinc. Let me go for the next one. How many total number of ClO bond are present, double bond O, in the structure of perchloric acid? Let me see the perchloric acid. Perchloric acid is HClO4. That is perchloric acid, which has chlorine bonded to 3 oxygens with double bond and another OH group. So there are 3 C double bond O. This is with sp3 hybridization of chlorine. We have tetrahedral geometry. So answer for this question is 3. 3 C double bond O groups. Let me go for the next one. A compound C7H14 on ozonolysis gives 2 compounds B and C. B gives silver mirror test and a positive iodoform test. C gives negative test for both silver mirror and iodoform, means C doesn't. So this indicate here negative silver mirror test indicate that there is absence of CHO group, and iodoform test is also negative. That indicate in that ozonolysis CH3CO methyl ketone is absent for the C, but B has positive silver mirror test, means it has aldehyde group. Next, positive iodoform test means methyl ketone. Aldehyde with that CH3CO group and responding silver mirror, this is only the possible aldehyde. So this is one aldehyde, whatever the product obtained here. That carbonyl compound is acetaldehyde. Another one remaining 5 carbons, we have to check that 5 carbons is not with the CH3CO group. So not with the CH3CO group means it is ethyl ketone, diethyl ketone is possible. So you can take this is the ketone possible. From this aldehyde and ketone, what is the possible alkene here? So here is the alkene. This alkene by ozonolysis we get acetaldehyde and diethyl ketone. This is the product obtained, means the possible structure for alkene. Here is the alkene. So they are asking what is the correct alkene. So options, what type of options given, that was not memorized by the students. So this is the possible product along with the other possible options given, whatever it is, but this is the correct answer. Let me go for another one. A solution has two elements. Number of moles N1, N2 and molecular mass M1, M2. Density of solution is D. Find molarity of second compound whose mole fraction is X2. This might be molarity of the solution. So molarity of the solution we have to find out. See, when the two solutions given having the number of moles N1 and N2 with a mole fraction X2 for the second compound. So X2 is equal to N2 by N1 plus N2. This is the mole fraction. Whereas molarity M is equal to number of moles by volume in liters, volume of solution in liters. So N1, that is number of moles of solute by, consider the second one is solvent. So solvent, it was given molecular mass and number of moles. So number of moles multiplied by molecular weight M2. This gives the mass of second, that is solvent, and mass of the solute is N1 into number of moles into its molecular weight. Now this is total mass of the solution. Mass of the solution, we need volume of the solution. So density is given for the solution as D. D is the density. We know from the relation density is equal to mass by volume. Now we need volume here. So mass by density. You can write here it as D. So number of moles here N1 into D by N1 N2 into M2 plus N1 M1. So this is the molarity of the solution. This is not X, it is simply density. So molarity, if they ask, actually options was not specified, so we cannot exactly derive the relation. Based on the option we can derive the relation. Let me proceed for the next question. The chromium complex CrCl3 dot XNH3 with concentration 0.1 molal is same elevation in boiling point as that of concentration 0.1 molar. So BaCl2 is 0.1 molar and the chromium complex is also 0.1 molar. Now here you can identify elevation in boiling point. Delta Tb is equal to I into Kb into molality. So I1 into M1 is equal to I2 into M2 molality for those two complexes, two solutions. I1 for BaCl2, barium chloride, which completely ionizes. Assume it alpha is equal to 1 because this is second group halide and heavy halides of second group, they completely ionizes. So N value is 3. Now I is equal to 1 minus alpha plus n alpha. If alpha is 1, so I value is equal to 3. And now you can see 3 into 0.1 is equal to I2 into 0.1. So I2 value is 3. I value for complex is also 3. With n is equal to, so from alpha is equal to 1, I is equal to, if it is 3, 3 is equal to 1 minus 1 plus n into 1. N value must be 3. 3 ions are obtained. 3 ions from the chromium complex. Here it was given all NH3 are within the complex. 3 chlorines, and it is possible to proceed with this here like this. That means the complex can be Cr NH3 5 times Cl 2 plus 2 Cl minus. So this is the number of ions 3 possible with this type of complex. From that, what is the X value here? X is equal to 5 possible. X is 5. Let me proceed for another question. An organic compound of mass